Hello, I'm Leon Butler, and along with Collin Rogers and Raymond Fernandez, we're the team behind Drawbot. Drawbot is an Arduino-controlled planar arm robot which takes an image file and draws it on paper. This is done by our program, which finds the edges in an image and determines a path along those edges. This process can also account for edge thickness by drawing over that edge multiple times. Our robot arm then follows that path on paper. Here are a few examples.
The project was implemented using MATLAB. Initially, an image is read into the system using our m-coordinates function. Here, edge detection is performed by the canny algorithm. Following edge detection, several morphological operations are conducted to obtain an image skeleton and prune unwanted points. Once the skeleton is pruned, paths are extracted from the detected boundaries. Paths are then converted to Cartesian coordinates in centimeters. These Cartesian coordinates are then used in our inverse kinematics function to compute the associated joint space.
Once our angles are calculated from our inverse kinematics, we can then send them to the Arduino. But in order to do that, we must first initialize it. In this case, we're using an Arduino Uno on COM8, and this is initialized within MATLAB. We then define each of the servos, servo 1 corresponding to motor 1, our first angle, servo 2 corresponding to motor 2, our second angle, and then servo 3, which corresponds to motor 3, which is our end effector pickup, so that we can pick the pin up off of our workspace and don't draw whenever we do not intend to. From there, we have built multiple prototypes of this arm and are able to change it by changing whichever COM our Arduino is set to at the time. Moving on, so in this version of the code, we have to call subarrays where our inverse angles are calculated and then give them to each of the motors, motor 1 and motor 2, responding to T1 and T2. Then we write the position and we do an entire boundary line, which is defined as from one point to another, where the pin will be drawing, and then we pick it up and move to the next boundary. Whenever all the boundaries are complete, the drawing is complete. And then we pick it up and we are finished.